Mr. Jeremy Meiss.
Hey, thank you very much. So I'm going to be talking today, and actually first I need to say something. So it's been, I wasn't going to do this. It's been 18 months since I've been at a conference. And I know that's like, I'm not the only one. Like, I think all of us are excited to be here. And so I just want to throw it out to Justin and his team. Again, I know we've said it already, it's just the first day, but thank you so much to his team and everybody that's made this happen, because otherwise I'd be in my dungeon in my house trying to do the ridiculous another virtual conference. That's a whole nother conversation for later. But so thank you, Justin and the team. Thank you for being here, and hopefully I won't keep you. I won't let you go to sleep. We'll have some in conversation, and then eventually we'll get to the margarita bar. So that's really all I'm here for right now, is just to get to that. So exactly. All right, so I'm going to talk about demystifying CICD, or kind of making the sense of CICD and current software development workflow. This is kind of some audience participation here. So imagine you're getting ready to ship some code. You've been spending a while getting to that point. You now have the proverbial red button that's put on your, that's right, that's ready. You're ready to release it. You press that big red button, and I want to hear everybody give me the sound that they want to hear when they hit that big red button. Okay, come on. She hyped me up. Had to have hyped you up. So come on. When we hit that button, what do you hear? Okay. Something takes off. Your software ships. That's the point. You've reached that. Everything you've been building towards now. There's a pun in there. Building towards. You're ready to go. Everything takes off, and then there's silence. So do you kind of sweat it out, wait to see if anything blows up, or I like it. Forget about B, just go straight with A. Just go right. So, or B, do you kind of pack up, go home, and enjoy your weekend? To me, B sounds like a whole lot of fun. The little kind of chaos monkey in me goes, yeah, push it, go away. But how are you going to know that nothing has gone wrong? Everything boils down to automation. When you're in software, when you're in code, you're pushing everything, and you're in that full life cycle, automation is everything. From software to process manufacturing, to yes, even agriculture, automation is taking over and is that very important piece. And while I'm not going to talk about agriculture today, I know from Kansas, and we got the corn and the wheat and flatlands, all that. I'm not going to talk about that, but I do like to kind of compare the software delivery lifecycle to growing crops. You constantly have to be on top of it. Any little change can really kind of ruin things. Now, of course, we've all seen the movies. Automation, when you start putting machines in charge of things, things happen. And I'm pretty certain that we're not going to kind of see the robot dinosaurs take on humanity. But after the last 18 months, I think we can probably say that we're not going to rule anything out. But automation malfunction can just as much ruin your crops as it can ruin and mess up your software process. The reality is that it's never really the machine's fault. It's pretty much always us. Every software failure is rooted in some type of error that we've probably done. We missed something, environment, we didn't account for certain things. It comes down to some error. All right, so as it was said, I'm Jeremy Meiss. I'm the director of DevRel and Community, Circle CI. Today I'm just going to be diving into CICD, hopefully kind of make it easy to get a handle on of what CICD means, why it's important for your software development lifecycle, and kind of as a jumping off point, hopefully for some of you, to either start implementing it into your company, your organization, project, or maybe even just kind of making some improvements to your already existing processes. So with that, let's go ahead and kind of define some terms so we're all kind of on the same page over the next 25 minutes or so. All right, so DevOps. DevOps is a set of practices that combines software development, so that's the dev piece, and then information technology ops, which would be the ops piece. And it aims to kind of shorten the system development lifecycle from being very convoluted and into kind of this continuous delivery with high software quality. Continuous delivery is that overarching principle that drives DevOps. So the key pieces of that life cycle kind of starts with planning. So initially you're setting out the plan of what you want to develop, what your end state is, what the type of application is. You're kind of getting that rough picture of, you've probably been given that by the customer or by some product manager. You're planning it out. Then you're starting to code the application for what the requirements are. The client, along with that plan, and so that this is your initial step is in that code piece. And then building. Once you start to build that application by performing kind of the integration of the various code pieces, the different modules, the different libraries, whatever it is you're doing, and you kind of get all of that put together. Then testing, and this is the heart of the application in my view. Testing that application that you've built so far, and then rebuilding the application if necessary, and test it until you've eliminated those errors. And I kind of want to call out Angie Jones is going to have talk tomorrow. That's right, woo! Right there, give it up for Angie. She's going to be talking about testing and kind of that importance of adding the eyes to your automation framework. So don't miss that. That's an important piece of this. So testing is the heart of the application. And then release. If you succeed in that test phase, then it's time to release that application into live. And then deploying. This is where, again, you're deploying into an environment, whether it be some cloud environment, AWS, GCP, maybe it's something you have on-prem, but you're deploying that for further usage. It's performed in kind of this manner that any changes that made shouldn't affect the function of the application or the website. It should be pretty seamless so that there's no downtime. And then operation, you're performing the operation on the code. If there's anything that needs to be done with it, you're using it. Then you're monitoring. And this is that kind of last piece of the life cycle there. And you're kind of making sure it is performing, hopefully catching things before they become an issue. There's a lot of software packages, tools out there that help you do that. And then you're making any modifications that the clients may have, and they always do. And then if you've reached the mark where it's ready to go, you get that rolled back in, and everything just starts back over again. You're in this constant cycle. So that's the DevOps life cycle. Now CICD, it's rooted in agile methodologies, and it embodies kind of the culture of a team or the company's kind of commitment to automation and DevOps principles, generally containing kind of a set of operating principles and a collection of practices which kind of enable your dev teams to release quality code more frequently and reliably, which is the goal. So the term fail fast, I'm sure hopefully everyone has heard that term. It's an important one in this whole process because it gives you, the developer, and the team specifically, the ability to know when stuff is breaking, which is invaluable. Instead of, you're able to get ahead of it. Fail fast. If you know it's done, you don't have to go through that full life cycle and find out now the customer is saying, oh, by the way, that thing's not working. It can lead to faster fixes and deliver of quality code. You can quickly fix those issues, resubmit fixes, and then deliver that stable code constantly. Now, so many years ago, who all has used Microsoft's Visual Source Safe? Okay, there's a few out there. Many years ago, thankfully many for me at least, the whole idea of source safe was kind of to do some of this, where you kind of, to keep you from overwriting code, hence the safe piece, that others were working on. Before we really had a lot of the, Git, SVN, were kind of in their early stages in some ways. And so, it would keep you from, like I said, overwriting code that someone else, in another team was working on, which in theory was good. But my experience, and I'd probably see some nodding heads here in a second, it usually kind of devolved into going on a hunt for that developer that had locked that entire directory instead of just the one file they needed, which also meant that you were going over, the entire building. Sometimes if you worked on a campus, they weren't answering their desk phone, because who answered the desk phone even then? Go around, find out they're on lunch, or they're on a 3-week vacation, and then you got to submit an IT ticket, and that never ends well for anybody. That was the challenge. So you had maximum loss of productivity. You have the code that, like I just said, you get all these different changes that are kind of going in their own little silos, which, when you're programming in that way, that's not terrible, but then you have trying to do all these merges into one piece. It's going to break some stuff. Then the testing, things usually mess up there, has to go back. It's a convoluted process, but there is a better way. So CICD. The idea is that everyone's working on the change, and as soon as you're done with that little change, you're pushing it to integration and testing so that you can see what you've just created is how it's performing against the your main piece of the code. And others can be doing the same. So as you're working on different branches, you're able to quickly see any of those changes you're pushing rapidly, hopefully multiple times a day, just so that instead of writing thousands of lines of code over a couple weeks, you're writing a couple hundred, and then it's easier to find those fixes, find what might be broken, and get it done before it gets out to the end state. So CI, would be defined as the practice of merging all developers' working copies to a shared code repository. And so in practice here, you're merging, if say you have a repo on GitHub, you have 10 developers. All 10 of them are branching from the shared code base, and so they have an individual silo of what they're working on, and then based on whatever that development environment is, as they write the code, continuously pushing that code up and getting it tested, figure out what's happening. And then, if there's any issues, can get that fixed before pushing it up to upstream repo. The next piece is kind of you're really running automated tests to validate your builds. As developers are merging those code base changes often, you want to have those automated tests so that you're validating them, so that you're pushing that code base up, so that those automated tests are ensuring the code quality so that you don't have to come back and do it all again. Again, only tested code is going to be integrated into the code base, and then the merging of those are frequently released to the production branches or the release branch, depending on how your team works within that Git flow. Continuous integration kind of gets us a speed so that once you write some code, you push it upstream, automation takes over, and then validates those builds, ensuring that you're only pushing quality code. That's the key here. Now, continuous deployment is really just automation. It's the practice of automatically deploying new software releases to target environments. Now, the overall chain of processes generally becomes, it's called a pipeline. It helps us with releasing software faster. You automatically get your source code changes and run them through the build, test, package, anything else that you need to do before you produce that release and get it out. It also means that you're delivering smarter and lowering your risks to the release, which your product managers and those in charge of that process are going to be extremely grateful. And then the code and software being released should always be at a higher quality as a result. And then using the continuous delivery mechanism there, you actually can lower your costs for time that your developers have. And actual billable items can also lower. You don't have to have multiple infrastructures as much because you maybe don't have to have staging, QA, and production. You maybe can trim that down, depending on how your company works. So CICD itself is not really a tool. It's a process. It's a set of principles and that in practices that you put in place that I've kind of just already mentioned. It breaks down those walls between development and between operations, gets everyone kind of working on the same page together. If you want to get a better view of what that work looks like, Gene Kim has written a couple of amazing books, Unicorn Project and brain just went blank on the other one. Check it out. Was that? Yes, Phoenix Project. So Unicorn Project and the Phoenix Project. Fantastic books, really help you understand a little bit more around what we're talking about this continuous delivery. All right, so benefits. I'm going to go through some of those pretty quickly here. The fundamental kind of tenet of continuous integration is really quite simple. You commit and integrate your code often, sometimes daily at a minimum. A few years back, about 10 years ago actually, when DevOps started to become this thing, Netflix was deploying, I believe it was hundreds of times a day. Like that was their piece. That's not, or I think it was like 10 times a day. That's probably not the best for everybody, but it's important. Sometimes, just a small change in your development process can yield those big results. So you may be thinking, like, just that one change, how is it really going to bring all of these, big benefits? When you're committing more often, you're identifying and resolving those merge conflicts earlier, and you can deal with them then, or you can even avoid them because of the way you've done your testing. So instead of, like I said earlier, writing thousands of lines of code and then finding an error, then you can only write maybe 100. And as you're pushing it up, you're able to test it sooner and find it, shipping more quality code quicker. All right, so shipping new features quickly means increasing your speed to market, giving your team a competitive edge in a couple ways, getting access to new features faster. You're also getting a faster return on investment. Business management, they all love that. All right, so going to go through these pretty quickly here, kind of some ways to implement CICD. Make sure everyone's on the same page. Make sure everyone's reading from the same playbook. And just start small. You don't have to go and integrate and do continuous integration and continuous deployment for all of your repos and all of your projects and everything you're doing. Start small. Take a little bit of piece, figure out what works, figure out the culture within your teams of how you can really get to this idea. Don't jump in all at once, because what tends to happen there is there's a lot of resistance to change, and you'll make it harder for yourself. And do what works for you. DevOps, it's as an overarching principle, continuous delivery, may not be the right solution for your organization from an overarching perspective. If confidentiality is a big part of your company, then getting fixes and new features out quickly, you might lose some of that competitive advantage because it's going out. So you might not have to be deploying as often, but you can still do some pieces of continuous integration. And then always measure it. Before you start any improvement plan, it's important to kind of get accurate measurements for where you're at now and see where it is, and then you can start to identify where you want to make your changes. So when it comes to software, like high-performing teams, what we've seen over the years is some certain benchmarks. So throughput is how you're getting code pushed out as often as you can. Duration to get those builds out is less than 10 minutes. Success rate of your CICD is going to be more than 90%. And then how long it takes you to resolve an issue should be less than an hour. Those are what we've kind of seen through the industry. So Some of those better practices make it an integral part of the dev process. Ensure that your testing environment mirrors production. That's a key. Use coding best practices, i.e. pair programming. That can be extremely helpful for everybody to kind of get a feel and work together and drive to get new ideas and get code, better code, higher quality code out there. Be more scalable too. And then automate that deploy workflow. Some are probably familiar with like Netlify and Vercel as just two examples. There's others out there, but they do a great job of helping with that deployment piece, automating it, and also with like the way they do deploy previews helps you kind of see, especially within web programming, you're able to see what it's going to look like before you do the full deploy. And maybe that may be where your actual production is, but that kind of workflow really fits. One final little thing I'll touch on here is we've done there's a couple of reports out there, like the State of DevOps reports has been around for a while. We did a State of Software Delivery report, and really kind of identifying with over, I believe it was about over 40,000 orgs, 50 million lines of code, how developers were performing and what were their best practices or better practices and ways of working. And then the global pandemic, we had some interesting things with that. So I highly recommend go out and get that report. You can find it at circle.ci/SSD2020. It's a free report. You don't have to sign up anything. You don't get on any email list. There's a lot of valuable information in there. So let's jump. One key piece, you don't have to automate everything. It is important to automate the pieces that can save you the most time, but this is not a call to go out there and get everything automated as much as possible and lose a lot of the important kind of getting the hands-on piece there. Start with the proof of concept. Goes back to what I said with starting small. Get your, set in place that integrated testing process, consistent software environments across your teams, get the training on those processes, and get your reports, measuring those key metrics, highly important. And it also, especially if you're trying to pioneer this within your teams or within your departments, even within your company, if you're at that ability to do so, helps to show the ROI. As if you can just start small and show how it works for you, and then build some relationships to grow that. So that's where I kind of come to the end. You can find me on Twitter. I am Jaredog. Got some Dev2 posts. LinkedIn. I've also started using that Polywork, so timeline.jaredog.me. Also have, like, if you would love to get feedback on the talk, or if you have any questions that, I don't know that we have enough time for that, but pop over to circle.ci/Jeremy and provide that feedback. Also, I can send you some shirts, send you some swag and whatnot. So thank you very much. Appreciate it. And find me. We can talk later. Thanks.